Hello and welcome to the deep learning course. Today we'll be starting a new part which is regarding the technical modules. So first project I've decided to make it in sentiment analysis, aka a hello world project. I decided to make it very simple in order to be clear of the pipeline. So without further ado, let's dive in. Basically, the project is as simple as is. Like it will be just classifying what are the reviews indicating a positive or a negative sentiment. So in that regards, we will be building a deep learning model. Like it will be a simple deep learning model using Pytorch library, and it will be predicting whether this text is indicating some positive review or a negative review. So first task here will be focusing on is transforming this text into digits, which is be called the encoder module. So we will be focusing on building it from scratch first, and then we will be using already made library using this Hugging Face part, which will be building it for us, but we need to dig further in it and to understand how it is being built. Okay, so I'll be walking through a simple overview of the Pytorch template structure. We will be aligning with what we are working on, and this encoder modules that we are going to build, where it will be inserted, in which part it will be inserted in this Pytorch wool template. So I'm insisting to make you understand first what is the wool image, and then we can work in the small pieces together. Okay, so this is just an alert, like it will not be just working through the Pytorch. We'll be moving on side by side to understand the Pytorch modules, but it will be just a simple overview of it. Okay, so first we will be understanding what is we going to make, what is the encoder going to transform our text into, and how this pipeline works. So first we have a corpus of data, which are a list of sentences that we are going to ingest to our model. So first of all, we need to tokenize it. So what is tokenization is? It is just breaking down this list of sentences into tokens. So a token should be a meaningful word, and sometimes it can be a non-meaningful, but it will be a decidable way whether the tokenizer is a good or bad. So for example, here you can see these digits is a token. Okay, a good tokenizer should separate this dot from the digits. So if this token, if the digits word repeated again within this corpus, we will not be creating a new profile or a new token to this as a singular. So a digit without dot should be the same meaning with the digit with dot. Okay, so a good tokenizer should have both have the same root. Okay, and also singular and plural should be all normalized. So all what I'm saying is can be under the umbrella of text normalization. So what is text normalization? In a simple way, it is first lowercasing all the letters here, and applying lemmatization and stemming. Which simple difference between them is like lemmatization is a little bit intelligent way to bringing our words to the root. Like for example here, tokenizing, it should be, if a good tokenizer is applied, tokenizing should be a token, just token, and we should truncate the ending of this word. So that is what stemming and lemmatization is working on. But stemming can be truncating the word into a non-meaningful word. Like for example, if we have these three derivatives of the change word, and we need to make it into the root, so we need to transform all this into the root. Like a stemming approach will be truncating all the extensions of this word, while lemmatization will have the ability to return a meaningful lemma, which is called the lemma. So that's why the two difference. So when should I use stemming and when should I use lemmatization? Well, a good approach to make hybrid, but if you need a fast truncator, so you should use the stemming because it's very fast, but it can return a non-meaningful or incorrect tokens. Okay, and sometimes can be pretty bad using stemming alone in some tasks, but if you know the distribution of the data, then it can be manageable to use this stemming module because of the time. After this, we can apply also remove symbols, digits, emails, like as we removed here this symbol, and also the digits 5000 is removed from this. Okay, after this we need to create a vocabulary. So a vocabulary is nothing but to get all the unique words or all the unique tokens from this list of corpus, and giving each token a digit. Okay, like as we can see here, sequence have 1, machine have 2, padding has 3. So every token now is having a single digit. So it's somehow we are transforming step by step text into numbers. After this, we will be working on the encoder. So we'll be replacing all tokens into digits, which will be giving each token an ID, and then rewrite again this list of tokens into a list of digits. But another thing that we need, which would be the model need, is to make all this list as the same size. So that's when we use padding. So padding is nothing but adding zeros at the end of the list to make them all at the same size. So if the sentence like this, for example, have 5 tokens and these have 6 tokens, these also have 6 tokens. So we will be adding an extensions to all these 5 tokens list to make it 6. And it also can be applied in the reversed way, which will be truncating the 6 length tokens into 5 only. Okay, so it can be the same, both directions, whether we increase the small sentences or we truncate the long sentences. And it also can be a hybrid from both, because sometimes the data is having a too long review and sometimes a too short review. So we need to have a moderate size. So this will be decidable by which we should be plotting out the distribution of the tokens across each review. And we can have a threshold, so we can decide whether we can increase or decrease or truncate and increase at the same time. Okay, so this by which more or less what we are going to do through the encoder module. Okay, so now let's see what is the Pytorch template, and after this we'll be seeing where should we insert our encoder module, this pipeline, into this template. So basically it consists of, we can distribute it into 6 modules: the dataset, the engine, the model, the train and utilizations, and lastly the configs. So the dataset is nothing but it's pre-processing. Any pre-processing tasks need to be applied to the data, whether it is an images. It's not only for text here. We are talking about the Pytorch at overall overview. So dataset is applying any pre-processing on the batch of data before ingesting them to the model. So any pre-processing will be applied through this dataset. Text normalization will be applying through this module. Images normalization makes the image to gray scale, make them into 3 dimensions, 3 channels, 2 channels. Any pre-processing parts should take place in this module. After this, the engine, which will be the core part of the training and predicting and testing the model. So here we'll be running all these parts, the forward propagation, the backward propagation, etc., etc. And after this, the model, which will be building the layers of the neural network. So here we'll be building this. And then the Train.py, which will be concatenating or working, combining all these modules into a single script and running them in the training loop using this epochs constant value and training and evaluating in multiple epochs until the model reaches a stable accuracy. It also here, apart from initialization of the dataset for the train and evaluation part and data loader, which the data loader is nothing but breaking down the dataset into batches. And here it also initializes the model and the optimizer. So both these are being initialized in this single script, and then the utilization functions like custom methods and saving our models. Any helper methods can be applied here. And lastly is the constant or the configs script, which will be holding the learning rate, the loss, the device which you are going to learn, whether it is GPU, the number of epochs which will be training our model upon. Okay. So let's get to how we are going to insert our encoder into this. Okay, so I am going to show you the Train.py because this should be combining all the scripts. So basically it has three main parts. First thing, it is the data preparation. So we are going here to initialize all the dataset parts, and then we are going to define the model and the optimizer as have been mentioned before, and then we are going to train the model in the training loop. Okay, so our task here is focused in this part, the initialization of the encoder, which is nothing but having an encoder applied to the text data via this dataset instance. So when this dataset part is being run through this train and evaluation parts, the encoder will be applying its pre-processing to the text and transforming it into digits, and after this we ingest the data to the model. Okay, so looking again more focus on the dataset part, because as you can see here, we are sending the encoder instance to the dataset to encode, to transform this into text. Okay, so this instance, it will be transforming this text into digits, numerical value. So mainly it will be get item, the method which will be responsible for returning the final format of the data, which will be inserted into the Pytorch model. Okay, so the model will be taking an input and will be evaluating his output or its output with the label. So the dataset should return two parts, the input and the output, the X and the Y. And the model will return the Y predictions. So, and then we compare the Y, which is the label that the dataset return, with the prediction to evaluate the model accuracy. Okay, so the model will take this input and predict whether it is positive or negative review. And then we will be comparing this with the true label. So as you can see here, these two dataset types is in the tensor part, in the tensor format. Okay, so take care of these simple things. After this, we'll be having this selecting this patch, because I've seen we will be not inserting the whole dataset into the model, because sometimes the RAM is not too huge and the data is very big, so we cannot insert all the dataset into this dataset model at once, but we will be step by step or in a patches manner, we will be inserting this data into the model. So item here is nothing but the index of this batch index. So this will be, get item will be producing a batch of dictionaries. As you can see here, it is returning dictionaries, and after this will be returning these dictionaries into the model. Okay, so this is the main part that we are going to develop in our task today. We will be having a method called encode in our module encoder. Okay, and then we will be inserting to it the text tokens and should return the text in an encoded format, in a digitalized or normal numerical format. Okay, this is the component that we are going to build. So the encoder structure will be having this set of functionalities. First, we have this pre-processing pipeline, which will be cleaning the review, removing stop words, tokenizing it, and also drop the minimum length, whether some tokens have less than a certain threshold, like as a review with 2 words. So the model will not be accurate in this manner because the model needs some data also to determine whether it is positive or negative review. Like if you can hear sometimes like something called oh my god. So oh my god can be interpreted as a positive or a negative. So you don't know, you need more data to understand what is the review about. So in that way we are building this method which drop the minimum length. Any length of review, let's have tokens less than a certain length, we can drop it because the model will not be producing a correct answer to it. Also, creation of the vocabulary, it should be implemented. Padding and truncating, as we have seen, we have a certain threshold, so we can have both sides, like we can truncate the long sentence and increase the length of the short sentence in the same way. Okay, and the encode part, which is combining all these methods in this simple way, in this certain method to return a list of integers. As you can see, it is a list. It will take a review and return it as a list of integers. And then the decode, it might not be used through our project here, but it can be used whether we have a translation project or a translation task. So the translation will be taking input as a list of sentence and producing output as a list of sentence in a different language, right? So the model will be producing the output as a list of indices, not a list of text. So the decoder will be used to transform this list of indices into a list of tokens, so it can be understandable from the human side. And the code will be working on all of it. And here we are going to seeing how we can use this module. So the encoder will be just calling this encoder, and it will be applying this pre-processing part and creating the vocabulary. Okay. So for example, here it's how it can be used. As an encoder should be producing food is awesome in a numerical format. Okay. So lastly, we are going to have next session will be focusing on implementing these this module in Python. So if you can have the availability to pull this repo I have mentioning here, I will also mention through the description of the video, so you can work on it on your side and then watch the video which will be working together on building these functionalities step by step. See you there and good luck. Bye.